This is Lesson 6, Quadratic Functions and Their Graphs. So let's start with the simplest of quadratic functions, and that is y is equal to x squared. If we wanted to graph this, probably the easiest way is simply to plot points, pick values for x, plug them in, and see what the corresponding values are for y. So let's pick some values for x. If I pick x equals 1, y comes out equaling 1. If I put x equals 2, y comes out equaling 4. If x equals 3, y comes out equaling 9. Notice the points on the graph. Now if I go in the other direction, if x is equal to minus 1, y is plus 1. If x is equal to minus 2, y is plus 4. If x is equal to minus 3, y is plus 9. If I connect these dots, I end up with the shape that you see here on the graph, which is basically a parabola. Now there are some points of interest on this graph. First of all, what we refer to as the vertex. The vertex is either the minimum or the maximum. In this case, the vertex is right here. Okay? It's the minimum value. In this case, it's the origin. 0, 0 is the vertex. Also note that the graph opens up, okay? So that it starts from here and basically opens up. The other thing to notice is the axis of symmetry. The axis of symmetry is the vertical line that divides the graph in half. And you can see here the y-axis is the axis of symmetry, or simply x is equal to 0. So x is equals 0 is the axis of symmetry. The vertex is at 0, 0, and the graph opens up. But what about the general case where we have simply y equals ax squared plus bx plus c, where a, b, and c are real numbers? How do we go about graphing that? Well, again, we could simply plot points the way we did before, pick values for x and see what the corresponding values are for y, or we could develop some rules. There are some rules that relate to this, and let's discuss those right now. First of all, what we need to do is look at the coefficient a first. If a is greater than 0, in other words, if a is a positive number, then we know that the graph opens up, okay? So whenever a is greater than 0, the graph opens up. Now conversely, if a is less than 0, in other words, if a is a negative number, then the graph opens down. So immediately, just by looking at a, we know whether the graph opens up or opens down. So next we want to consider where exactly is the vertex. If we know whether it opens up or down, where is the vertex in relation to this? So we know the general shape of the graph, we don't know where on the graph it is. So let's start by looking for the vertex, specifically the x-coordinate of the vertex. So if we look at minus b over 2a, so if we take the coefficient b and the coefficient a and write it as minus b over 2a, that is the x-coordinate of the vertex, or simply the axis of symmetry, okay? So this immediately locates the vertex in terms of the x-coordinate. Now, to get the y-coordinate of the vertex, you simply plug this value into the equation, the original equation we had for x, and solve it for y, and that'll give you the y-coordinate of the vertex. So, by looking at a general form of the quadratic, a tells us whether it opens up or down. The value minus b over 2a gives me the axis of symmetry, or the x-coordinate of the vertex. And if I plug that in for x in the original equation, I'll get the y-coordinate of the vertex. So now let's look at a specific example. Let's say we have the equation y equals minus x squared minus 2x plus 3. Now notice, in this case, a is equal to minus 1, b is equal to minus 2, and c is equal to 3. So how would we go about graphing this? Well, first of all, we notice since a is negative, this graph is going to open down. And next, if we look at minus b over 2a, that's going to be minus a minus 2 over minus 2 times 1, or in other words, it's going to come out equaling minus 1. That's going to be the axis of symmetry. And if you'll notice, the axis of symmetry is right here, basically. So x equals minus 1, there's your axis of symmetry. It's also the x-coordinate of the vertex, which is up here. If we plug minus 1 in for x, we'll come out with y equals 4, which is the coordinate of the vertex. So the vertex is at minus 1, positive 4, opens down, and we end up with this graph here. Now, there's a couple other things we need to notice here. There are some interesting points here. First of all, the x and y intercepts. Let's look at the x-intercepts. The x-intercepts are right here, where it crosses the x-axis in two different places. These are actually the solutions of this equation, okay? So, positive 1 and negative 3 are the roots or solutions of the equation y equals x squared minus 2x plus 3. Now, the other point of interest is the y-intercept. Here's the y-intercept up here. The y-intercept is where x is equal to 0. Well, if you look back at your original equation here, and we set x equal to 0, that term goes away, and we get y equals 3. That's the y-intercept. So the y-intercept is where x is 0. The x-intercept is the solution for this equation. In other words, where y is equal to 0. And with all these points, with the vertex, knowing it opens down, and the intercepts and the axis of symmetry, we can get a very good idea of what the graph looks like. Now there's another form of the equation, and it's sometimes referred to as the completed square form, as opposed to the general form which we just talked about. The completed square form looks like this. If we've got y minus k is equal to a parentheses x minus h parentheses squared, okay? This is a quadratic, but it's just a different form of writing the quadratic. This particular form, however, really makes it easy to take and figure out how to graph the parabola. Now, just as in the previous form, the general form of the quadratic, we start with the coefficient a, and if a is greater than 0, or if a is positive, the graph opens up. And just as before, if a happens to be negative, the graph opens down. So if a is positive, it opens up. If a is negative, it opens down. Now this is where it gets easier. Notice the values of h and k. H, k are simply going to be the coordinates of the vertex. So you know whether it opens up or down. You immediately know the coordinates of the vertex from the values of h is the x-coordinate and k is the y-coordinate of the vertex. Now, in terms of the x and y intercepts, same as before, okay? We solve this for setting y equals 0 and solve for x, and you'll get the x-intercepts. You plug in x equals 0 and solve for y, and you'll get the y-intercept. So now let's look at a specific example. Let's say I had y plus 2 is equal to the quantity x minus 3 squared. Again, we notice a is, in this case, is 1, which is a positive number, so it's going to open up. H is equal to 3. K is equal to minus 2. That means the vertex is going to be at x equals 3, y equals minus 2. And the graph would look something like this. Notice on the diagram here, the vertex is at x equals positive 3, y equals negative 2. It opens up. We could take and plug in x equals 0, and we'd end up with y equals 7 for the y-intercept. And similarly, we could find the x-intercepts by plugging in y equals 0. So this concludes this lesson. Now proceed to the worksheet.